So hi, my name's Steven Wilsons. I'm a program manager on the media team in the operating system group at Microsoft, and I'm really excited to be able to have the opportunity to talk to you today about screencasting. So today we'll learn how to develop multi-screen device applications using casting technologies in Windows 10. At the end of the session, there's an evaluation, so please give the feedback we need. It's very important to me to get the feedback so I can continue to improve and we can all get better together. So today in the market, there are a lot of devices, screens, and protocols out there. And what users really care about is they want to be able to transfer their content from a small screen device to a bigger screen out there. There are different standards and operability that can make that tricky for developers today. And our goal really with Windows 10 is, and this is my promise to you, we're trying to make sharing content intuitive, reliable, and simple for both developers and for consumers. So that's my promise. One of the things we did at the end of Windows 8.1 is really we looked at what was some consumer feedback we were getting. And some of the consumer feedback was that it was really hard for users to discover the play charm that existed in Windows 8. Another issue that users ran into was that they couldn't actually cast to a device unless they had already previously paired with that device. So that was an issue in discoverability. Additionally, devices were only discoverable on private networks, and you had to make some network changes before you could actually discover a device on public or domain networks. Users also wanted to be able to cast more easily to other devices than just DLNA Play 2 devices. We consistently got the feedback that it was really confusing to understand what the difference was between Play 2 and Project, so we tried to fix that. And people just said, Play 2 just doesn't work reliably enough. And we agreed with that. From a developer perspective, developers really gave us the feedback saying that, hey, the APIs are too hard to use in real-world applications. Device selection really should be a BMI application, and it shouldn't be hidden in a charm where it's hard for users to discover. They really wanted to be in charge of the full experience themselves. They also asked for support for more devices, which basically means support for more protocols. And they wanted to have converged APIs across all platforms. Because in Windows 8.1, some things you could do on mobile, some things you could do on the Windows desktop, and it was really a confusing situation for developers. So here's what we invested in. First thing we did is we converged all APIs across all of our Windows platforms. We really worked on improving reliability and telemetry. We made it easier for developers to do very common tasks. If you easily want to add casting to your application, we made that really easy for you, and I'll show that later. We added wider support for common protocols out in the market. So aside from DLNA, you can now use Miracast, you can use Bluetooth, and you can use the dial protocol that Chromecast uses, for example. And one of our main goals was to empower the developer so that they can add casting to their application in the way they want to add it. And they can choose from the technologies they want to leverage. So in Windows 10, how can users get their stuff or media from one screen to another? There's two types of connections. There are system-level connections, and those connections really persist throughout your Windows session. So it's really like the old Project that you knew. You can connect to another device using a cable or a Miracast device or to a Bluetooth endpoint. And as you move through applications, that stays consistent. And there are application-level connections. So application-level connections now are really in the hands of you, the developers. So you can use our Windows 10 APIs to add casting in the way you want in your application, and that connection is really persistent for your app only. So as I said, system-level connections, you can connect to an external device, external screens. We support cable and Miracast. For audio, we support a cable, USB, or Bluetooth. Miracast has been one of the focus points for Windows 10 for us. In Windows 8.1, we added Miracast pretty late in the product cycle, so we really asked the device vendors to add a lot of that functionality in their driver. And that really resulted in a different experience as you had a different driver on your system, as you had a different vendor. So what we did in Windows 10 was we took a lot of that implementation that was in the driver and we put it in Windows. So that way, we can make it more consistent, and we could really add a lot of telemetry to figure out really what is not working. With the telemetry, we really want to figure out what is the device that is failing for us, and how can we make that better? Where is it failing? And then we also added a bunch of OS enhancements using the Miracast standard and Wi-Fi Direct standards. So some of those enhancements are fast IP assignment, so you can connect quicker to a device that supports that. We added other enhancements like UIBC, where if you connect to a Miracast endpoint and that endpoint supports touch, you touch that device, and then that touch event actually gets sent back to your sending device, as if it was a local touch. That's pretty cool there. I want to give you some insight on what we were doing with Miracast telemetry and reliability. So this is like a demo slide of the funnel we have, but it gives you an overview of what we do with telemetry on an IHV and a Miracast implementation level. So each of these layers represent our success levels and failure levels we have or could have. And what we're doing really is that as you drill into these, we can really figure out what are the errors we're getting and what's the most important error we need to fix in order to get better. And we just don't look at that on a global level, let's say all Windows. So we can really filter those funnels down to what's the exact build number, what are the drivers that are being used, what is the sender hardware, what is the receiver hardware, what is the firmware version, etc. So we can be very detailed about diagnosing issues. And my promise regarding to our reliability is that now we continuously look at those reports. Like every day we look at those reports and we're really trying to figure out what are the issues we need to fix. Next slide. So for Miracast devices out on the market, we've really been working closely together with ActionTech and other partners to make sure that we have a great experience with popular Miracast devices out there. The ScreenBeam Mini 2 and the ScreenBeam Pro have a beta update available that you can download today that lets you take advantage of those Windows 10 enhancements that I was talking about. So you can have a better user experience, or you can connect the keyboard to your receiver device and just start typing as you're projecting, or you can get better connection, etc. So the slide here is that if you download the ScreenBeam configuration utility and you just select firmware update, you can go to beta and you can get that update on your device. So the first demo I want to do today is just quickly demo how the system level connections are a little bit different today than they were in the past. So if I use Windows key, so what happens right now is that all devices are being, that are Miracast capable are being listed here. And what's the difference with Windows 8.1? All devices that are on that I can reach are there, not only the devices that I've paired with. So when I then click on my device, magic is about to happen on the other end. So now I'm in extended mode and I have my application on the other side. I can move my Visual Studio app around if I want to, or I can move it back. You can go to duplicate. This is pretty much what you've known in the past. Afterwards, if you want to disconnect, it's pretty simple. So that's pretty much the intro to the talk. Now we're really getting to the juicy part, the application level connections where developers are in charge. So there are 3 ways you as a developer can take advantage of the new APIs in Windows 10 to cast your content. The first one is called media element casting. And what that is that any content that is played in a local media element can now be sent over to a receiving device. And those receiving devices can be Miracast devices, Bluetooth devices, cable, or a DLNA device. So those are all the devices you can target with media element casting. And as you see here, there's a default cast button in the media element that already has casting enabled. So if you're just playing video in a media element, you get casting for free now. Second one is remote app launching. So remote app launching is really, we're taking advantage of the dial protocol, which is what Chromecast does. And we are allowing you, if you have an application on your handheld device, to launch a companion application on the big screen device and start playing the content there. It's really a great opportunity for users if you want to just break into that market. And there are multi-view apps. What are multi-view apps? Multi-view apps take advantage of the Projection Manager API, and they allow you to basically, from your local sending device, create two views. One of those views is being rendered locally, and the other one is being rendered on the other screen. And that actually uses Miracast as a technology as well. So media element casting, as I said, anything that plays in a media element or a video or an audio tag can be casted to either a Bluetooth Miracast or a DLNA device. What we did in Windows 10 was, aside from adding support for the protocols, we did remove the play charm, as I said. So that charm is not there anymore. That also means that we had to deprecate the Play2Manager API that existed in Windows 8.1. That API really heavily relied on the charm. So if you have a Windows 8.1 application and you run that on Windows 10, what will happen is you will never get a device selected event anymore. And so basically the Play2Manager API is dead. And then you can use the casting APIs to add casting back to your Windows 10 app. The nice thing is that in the media element, you get casting for free because it's just included in the new transport controls that are there. One of the nice things we did is that for Project Spartan, we added casting to that application by just using the media element casting APIs. So that's just a way for us to reuse our investment, but it is also a validation that you can do very complex things with this API in your own app. So when do you want to use media element casting? If you want to add casting at a lower cost, you want to reach a large set of devices with one API. If you don't need any customization on the receiving device, because basically what is being sent over is the media that's playing. It's also important that you understand the capabilities of different protocols that you can use using media element casting, and that you're aware of the battery life impact when you're sending content, because you're downloading it on your small screen device and then you're sending it over directly. All right, so this is the first time we'll be doing a demo, one of many. First thing I have here is, Visual Studio not drawing correctly. What I did is I created one screencasting sample, and the screencasting sample is available as part of all the Windows samples, the Windows 10 samples that will be distributed. We'll be going through this sample one scenario at a time. So the first one for media element casting, what I said was media element casting is so good in Windows 10 that all I have to do really is add a media element. All I have to do is add a media element to my page, and then from then on I can start casting. So let me show you that. So as I start playing my Big Bug Bunny video, I can now cast it to my Miracast device. Give it a second. Ta-da! So that was very simple. So just by using that media element, I can now cast to another device out there. There's still a bug there where we actually don't immediately close the application on the other side, but we're working on that. So the second, let me switch back. Aside from using just very simple casting, what we also did is we introduced the device picker control you saw me use to select the device. And that device picker control just really is an easy way for you to list devices, and it provides you all kinds of inline pairing ceremonies. So it's just, you can specify a filter for it. So you could say, hey, I only want to see DLNA devices, I only want to see Miracast devices, I only want to see dial devices, or I want to see all these devices together, and that device picker control allows you to do that. And as you click on a device you haven't been paired with, that picker control will also just, as I said, take care of all the pairing that is needed. So how do you use the picker control? It's very simple. You simply declare one of the flavors of the picker control. You subscribe to a device selected event. So when a user clicks on the device, and you can customize it. So you can customize things like foreground color, background color, selected color, etc. Once you've done customizing the picker, you can show it. Then the picker shows up, and the user can then click on the device. So once the user's clicked on the device, you get the selected device back, and then you can start casting. So with element casting is that as you get the casting device back, you just make one call and you say request start casting async, and you use the casting source from the media element. So it's that easy to kind of replicate what I had done before. So what I wanted to show in my next demo is how can I use media element casting but add my own custom button, and we'll use that paradigm throughout the session. So the first thing I have here is my media element again. So for my media element, I made it a little bit more fancy, and I added custom media transport controls. And those custom media transport controls will have my custom button. So if I look at those, under controls, what you'll see is that these transport controls simply have a way to get to the custom cast button. So I just get my template child from my custom template. And on that button, I subscribe to the button clicked event. Once that button clicked event is actually raised, I raise an external event to which I'll subscribe into my page. So now I said, hey, I have a custom style. Well, how do you get a custom style? The custom style here is based off the generic XAML style that is available in your SDK. And I just started customizing it, and let's see, go to my bookmarks. First one I have here, this is the default style. These are the default media transport controls, and what happens here is that there are a bunch of buttons in there, a stop button, a rewind button, volume button, etc. But there also is a cast button. Right? So this is the default cast button you saw in the previous demo. But what I did now, in my own implementation, in my own XAML file, I removed some of the buttons that you saw before, and I removed the default cast button, and I called it my custom cast button. So now I can actually subscribe to that event myself. And that's really what you've been seeing in the custom cast button here. So if I go back to my code, I have my custom transport controls, and in my constructor here, I first get the video, right? And what I do here is I get the transport controls on my player, and I subscribe to the cast button clicked. So when the cast button clicked event is fired, what I simply do here is I pause my player, and I show the picker. Once the picker is shown, I get the picker device selected event. And as I get the casting device that was selected back, what I do here is I create a casting connection, I subscribe to all the events, and I start casting right here. I start casting to the selected device. So as you see, there's a little bit more going on here than in the previous demos. What is also important to know is that when you actually use the picker, what happens is the picker control runs in a separate process. So as you actually would break into the debugger, the picker process is actually dismissed, and the selected event, the selected device you get currently is actually becomes null. The way to work around that is that as before you break into a debugger and you would set a breakpoint, is to actually get a local copy of that device and not the proxied version to the other process. It's something we're working on, but I do want you to know that's something you'll have to do if you want to debug your application. All right, so pretty much the same demo here. I have my default media element, I have my video playing, I have my custom cast button that now you can see is black because I customized it. Once I select the device, content starts playing on my second screen again. The next way to enable casting in your Windows 10 app is remote application launching. And as I said, we use dial, so it stands for discovery and launch, and that's really what it does. It discovers your device and the application on the other side, and it just launches it. The way that works is the following. So a client really discovers all the dial-enabled receiver devices on the network, which could, for example, be your Xbox. Then you get a UPnP description back for all the receiving devices. So now I know all the devices that are out there, and I can really start listing them inside my device picker. We ask for the application state for each of one of those devices, and then when a user clicks on a device, I can launch the application on the other side with a set of launch parameters. And that's really where dial gets out of your way. So you discover the devices. Once you found the device, then you're just launching it and giving it a string parameter. And then you really have to, as a developer, implement that app-to-app communication yourself. So there's a sender and a receiver part through remote app launching. And from a sender perspective, yeah. Oh, sorry. So from a sender perspective, what happens is that we converge all the APIs across desktop and mobile platforms. So we also are supporting dial 1.6.4. We're working on implementing version 2.0 as well. And the APIs are integrated in the device picker control and everywhere else in Windows 10. So from a receiver side, we've supported dial on Xbox One since August 2014. So and some of the major applications out there are currently already supporting dial on Xbox. So when do you want to use dial? You want to use dial if you already support dial on other platforms. Because at that point, really, also supporting dial on Xbox is just a very small step for you. If you want to provide a customized experience on the receiving device, because you actually are running an app on the big screen, you can just customize that experience as much as you want. You also own the communication between those two apps, so whatever you need to implement there, you're in full control as a developer. And you also want to take device compatibility out of the equation, because dial actually is such a small protocol and it's so well understood. The different devices really behave really well with dial, and you don't have any of those issues. As you're using dial and you're sending media across, but most of the time you send across is a reference to the media in the cloud. So what you actually get on the sending device is great battery life. Because once you're actually sending the content, that device is really, you just send the reference and the content starts streaming on, let's say, your Xbox, and any work on the sending device is done. Next step is me showing you how easy it is to add dial in Windows 10. So you can use a dial picker flavor. And what you simply do there is like you specify a filter. And you say, hey, my dial application name is, for example, Contoso Video. And what that'll do is that once somebody brings up that picker, we'll make sure that we only show the dial devices out there that have Contoso Video installed. Once the device is selected, call the picker device selected method, and an equivalent method for disconnecting. When somebody clicks in the transport controls, the picker is shown. And when the user then selects the device, we're getting ready to dial cast. The way we're doing that is we grab the dial device, we're updating the picker, we're saying, hey, we're connecting. We're getting a local copy of the selected device so we're calling get dial app for Contoso Video, and then we're really launching. So we say app.request launch async, and we pass in a string. The string is an example, but it's a pretty good example of what you, for example, could do for casting media. We have a pairing code that allows the two applications to rendezvous in the cloud. We have a reference to the content you're currently playing so that you can easily pull that down before you actually have done the rendezvous. And then we have a time offset where you basically, the position and where you were in the video. Once dial on is succeeded, you can set the picker status to connected and it will hide itself. Disconnect is very similar. When a user clicks on disconnect, you get the dial device that you want to disconnect from back, and then you can call stop async. Depending on how the dial server implements stop async, the application could just be stopped, or it could completely be terminated and unloaded from memory. If you don't want that type of behavior, you could just use your app-to-app communication and just literally stop local playback if you want to. Once stop async is completed, I'm updating the picker status and I'm saying, hey, I'm disconnected, and I'm hiding the picker. So that was how you quickly add dial on the client. This is how you add dial on the Xbox One using the Windows 10 implementation of Xbox One. So in my manifest, what I'm simply saying is that, hey, this application, it supports dial, and Contoso Video is my dial protocol name. So it's very simple. So what happens now, as soon as that application is installed, and somebody queries for a dial device that has Contoso Video as an app installed, the Xbox One is being returned as one of the results. When the application is then being launched, so when the user selected the device, the onActivated event in your application is called. And what we did is, as part of the arguments, we're telling you that you're being activated as a dial device. So if you're being activated as a dial device, pretty much it's time at that point to start parsing the arguments. So these are the string arguments that we discussed earlier before. I'm getting the video ID, I'm getting my position, and I'm getting my pairing code. From then on, I'm playing the video. All right. So let me show you how that works in action. So I have my Xbox One on the one side. Let me look at time, and the time clock didn't start. So what's happening here is that I have my Xbox One, and I have my local application. I have the code here for the dial sender and the dial receiver. So as a dial, on the dial sender side, I just have my media element with my custom transport controls and my custom cast button. Then in the code here, when a user has actually selected a device, I am going to start casting. And so what I've shown you before is this is a little bit more complicated version of the code than in the deck. But what happens is that I'm calling the picker, and you see this is like wrapped in a really nice try-catch block. It's the way to do it. The reason for that is that if I break into the debugger, as I said before, the picker actually doesn't exist anymore and is being dismissed. So right now, if I'm in my debugger, picker.setDisplay status will fail. That's just why that's in the try-catch block there. What happens further in the code is that based on the dial device ID I'm getting back, I'm getting my dial device, and then I'm getting my dial app instance based on the name. So if the dial application exists, what I'm doing here is that I am launching my application on the other device. Once that is being launched, really this is where all of the app-to-app communication needs to be instantiated, and you need to rendezvous yourself. So that's what happens on the sender side. On the receiver side, what happens, you have the onActivated event that's being called. Oh, yeah. Sorry. You have the onActivated event that is being called. So as I said, in the onActivated event, I am just checking the activation arguments and find my activation kind to be dial receiver. If it is dial receiver, what I will do eventually is navigate to my receiver page. Then in the receiver page, I will parse out the dial arguments as you've seen before and start playing the video. Basically, I am just roughly launching the app with the video I got passed in, and the app-to-app communication is really part of this demo right now. All right, let's show that in action. So I have my video playing locally now. When I click on my device picker, I'm filtering it down to all dial devices. And I'm seeing my Xbox on the other side. Now if you look on the other side, oh, it crashed. That's great. Something did not go well. Let's try that one more time. There we go. And you see the app is now playing the video on the other side.
We have main engine start. 4, 3, 2, 1.
Boom. How great is that? Pretty cool, right? So the other part, what's nice about this application is that, I want everybody to kind of internalize that, this app is really running locally, and it is running on the Xbox. So that's really the great part of that. The way you actually debug and deploy on the Xbox is simply by going to Properties. Once you have an Xbox One that runs Windows 10, as a remote machine, you type in the IP address of your Xbox. You'd save that, and then you can just deploy it to your remote machine. So that's pretty great, pretty cool. I'm going to try and deploy it to the Xbox. There might be the remote debugging service that might have stopped, and then we'll just have to start that again. All right, so that did stop. All right. So what I'm doing now is I'm just connecting to my Xbox. And then, so this is hopefully something you would never have to do yourself. So now the debugger should have been restarted on my Xbox, and if I now deploy my application, what failed before should work now. So as you see, I'm just running the app now locally on my Xbox. It's loading the app. It'll load it to a default page that shows you a still video of the casting part. So that's really how easy it will be to develop Xbox One apps. So I have my Windows Universal app that I can have be a sender on the client side, and once I deploy it to my Xbox, all of a sudden it's a receiver. So that's pretty great. Again, that's pretty cool, right? All right. So the last way to add casting to your app are the multi-view applications. We're back. So multi-view applications, as I said, is you can generate two different screens from one device, and then project that second screen on a Miracast device or on a connected cable device. So what we did in Windows 10 was we really converged those APIs across desktop and mobile platforms. Those existed more or less on desktop before. They now are completely functional on mobile as well. We integrated them with the Windows 10 APIs and the device picker control you've seen before. And one of the big changes that was made from Windows 8.1 is that you can now select the device you're casting to. Back in Windows 8.1, you had to first instantiate the Miracast connection, and then you could connect to that device and render those two screens. Now you can really just pick that from within your APIs. So when do you want to use multi-view applications? With multi-view applications, you really can customize what is being played on the second screen. So as I said, that's a second view you're rendering, and you can render that view as custom as you want to. And if you want, by doing so, you really take advantage of the Miracast improvements we've made in Windows 10. How do you add support for multi-view apps? Again, it's pretty simple. Once a user clicks on the casting button, what you do is you instantiate your picker control. You add a device class saying, this is my projection device. Once the device is selected, the picker device selected method is called, and I'm showing my picker. If you've ever implemented multi-view apps, you'll know this is a very reduced version of what you really have to do to instantiate those two views. But once you have the two views instantiated, you just call projection manager, start projecting async. You pass on the two views you've created and the selected device ID to which you want to start projecting. All right, next demo. So what I did here is that I created my multi-view application. My multi-view application locally, again, just has my media element with my custom casting button. And what I do is, as I'm casting and as I'm generating my second view, I am instancing the projection view page. And that page, aside from just having the media element on there, it actually has another set of transport controls. But you can pretty much put on there anything you want. But what I did want to do is highlight the difference. So when I first was using media element casting, what happened on the second screen device, I couldn't really pause the content there because there weren't any pause play controls or transport controls there. So I wanted to add those. And I'm adding these by using the multi-view app system. So these controls are a variant of the transport controls you've seen before. What I did do is I added a stop projecting button to those, for example, and we'll be using that. Oh, I'm doing it to my Xbox. There we go. So I have my application buffering the video here, playing the content, filtering down to Miracast devices in my neighborhood or monitors. This takes a little second. Launching the second view on the other screen, and as that happens, you'll see actually just my media element, what it does, it starts buffering the content and starts playing the content on this other screen. Additionally, I have my custom media transport controls I added there, so I can go into full screen if I want to. I can stop projecting, I can switch the views if whatever I need as a user. It's pretty cool. I'm pretty excited about this one, especially since as a developer, you can really start choosing which of these technologies works well for you and which of these technologies you want to take advantage of. So that's my biggest point of the day is that as we've discussed these different levels of casting, you can really start combining them. So you can combine media element casting, remote app launching, and multi-view apps in your code to make sure that you really create the best possible experience for the device your user selects. What that means is that if they select a dial device, you want to use dial. If they select a Miracast device, it might be really good to create an experience that takes advantage of the multi-view app system to generate that second screen in a custom way. But if it doesn't support any of those, what you could do is then you take advantage of the media element casting APIs and just simply render the video on the other side. So what I've done right now is that I'm targeting Miracast devices, I'm targeting dial devices, I'm targeting DLNA and Bluetooth devices out on the market. And for a user, that is one experience. I have one cast button, I have one way to connect to it, I have one list of devices I have to choose out of, and I get the cast experience that is the best possible experience on that device. The way you do that in your application is by adding the device picker control. So as you add the device picker, you start adding filters. So the first filter I'm adding is the Miracast filter. So I'm saying, show me all Miracast devices. The second one is, show me all devices that can render video. So those then are my DLNA devices. And the last filter is, show me all the devices that support dial and have the Contoso video app installed. When a user has selected a device, fire the picker device selected method and show the picker to the user right now. So that's what I'm doing here. So on the second screen here, a user's really clicked on a device. So what I'm trying to figure out in the simple version is I first try to see if all right, the device that is selected, does that device support dial? If it supports dial, I want to use dial, so I'm starting my dial casting right here. I'm getting the dial app, and I'm calling request launch async. Secondly, if my device did not support dial, I'll check to see if it supports the projection manager APIs using Miracast. If it supports those, then I can start projecting that custom view you've seen before. If my device does not support dial, and it does not support Miracast, because of my filter, I know it will either support DLNA or Bluetooth at this point. And I can target those using the casting APIs. So that's kind of my last resort here. I'm using the casting APIs, and I'm calling request start async on the casting source that was playing in the media element, and I'm hiding my picker. So that's really a great way that you can add all of these together. And I have a sample on that. So in the sample here, as you download it, the first thing that you'll see is that right now, if you download the sample today, there's two things I have to warn you about. First, the APIs don't work in the current build of Windows you'll get, but they'll soon be fixed. Secondly, you'll see there's some small workarounds right now, and as we resolve our bugs, I'll keep updating the sample. So as you download the sample with the corresponding build, you'll see the code become cleaner and cleaner, but I really didn't want to hide anything from you. So what you'll see today is, in this scenario, is that let me walk you through it. What I'm doing here is I'm subscribing to my player events so I can update the status. I'm getting a video from my data provider. I'm setting the source locally, and then I'm subscribing to the clicked event on my custom transport controls, and I'm creating the picker. Now, and then I'm subscribing to all of the events that my picker offers. So device selected, disconnected, and dismissed. So when a user is connected to a device, the disconnect button will show up. When they click on the disconnect button, the disconnect event will get fired. If they bring up the picker and they don't select the device, so they click next to it, the dismissed event will get fired. And then I'm adding the filters, and that's really where the kicker shows in right now. For dial, there's a custom filter I specified here. Normally, you would just be able to call dial device.getDeviceSelector. That filter is currently incorrect, and the same goes for on casting device get device selector. They all don't play well together when you're combining all these technologies. And lastly, there's the projection manager filter you saw. So then when a user selects a device, so pick a device selected, I get the ID of my device. I have the device information object. The device information object is just a general representation of a generic device that is being selected. And what I'm doing here is that first I'm really trying to use dial. If dial failed, I'll use my projection manager API. If that does not work, then I'll use media element casting. And as you go into all these methods, they're really we're really revisiting what you saw with all the individual technologies there. So if I run this sample, what's nice about this at this point is that if I start playing content here, I can really select, I could either select my Xbox or my Miracast device to cast the content to. So from a user's perspective and with Windows, I'm coming back to that promise I made you, is that you can now target the widest set of devices out on the market with different APIs supported than Windows, but we create one user experience. So that's pretty great. So as a summary, with Windows 10, we're allowing developers to reach the broadest set of devices in the market using the broadest set of protocols. As a developer, you really are empowered to add casting to your application and add it in a way you want. You can use the device picker control. You can choose not to use the device picker control. You can mix and match all the different casting technologies you saw here before. Ideally, my call to action is that as you are working on this, please try to combine them and create just great experiences in all the devices out there in the market. I want to thank you for your time today. I have time for questions, and then please take some time to evaluate the session as well. Your feedback is very valuable to me. I want to thank you for today. Thanks.
I have a quick question, actually.
Yep.
Regarding Chromecast or AirPlay, do you have any plans to support this?
So we
protocols?
support Chromecast. Sorry, the question was, do we support Chromecast or AirPlay? We currently support Chromecast as a device because they use Dial as a technology still. So as you implement Dial on Windows as a sender, you will be able to target the Xbox One, a Chromecast device, Fire TVs, and other devices out on the market. So it's really pretty broad. Perfect.
So for the Chromecast, I think we should still implement the receiver app on the Chromecast side, right? In order to support.
The question is, should you implement the receiver app on the Chromecast side? Yes and no. Because what you can do is that on Chromecast, there actually is a default type of application that exists there, and you could target that default application if you want to, even using Dial.
Right. So what about closed captioning handling on the receiver app side? Do we need to do anything for closed captions?
It depends which type of
Device.
which type of device, really. Yeah.
Okay, so if we need to implement the authentication on the streams, so do we need to handle it from the sender side, or is it again the device specific?
So what happens with authentication on the stream is that it depends on the technology, but let me go into detail on that a little bit more. If you do element casting and you say get as casting source, what we really filter the list down to is any of the devices that support the content protection you're using, right? So that's what the media element casting. And then with Dial, you really are in control yourself. It really is the app that needs to determine whether the content is allowed to play or not. And it is very similar if you use the projection manager APIs, because what you're really doing is like you're playing the video locally. So yes, you have to do some work even with the projection manager APIs, but it shouldn't be a lot of work. You should be able to easily add that yourself.
Hi, the Dial stuff, can I use that just to pair two apps together on two different machines, or is it only for video?
So the question is the Dial app only for video, or can I just use it to pair applications on different devices? It really is not restricted to media.
Okay.
But what oftentimes is the case, the Dial service that is running is most of the time only implemented on media receiver types of devices, like Xbox, like Chromecast, like TVs and such.
Okay. Second question is, can Windows 10 act as a Miracast receiver? Let's say I want to use my Surface 3 Pro as a second screen.
It currently does not.
Okay. Will it?
Maybe.
Okay.
Yeah. Any other questions I can help with? There is not a default app right now. Sorry? Yeah, there is not a default app on Xbox One now, but we have that as something we really want to start working on now. But we were really focused on getting all the plumbing to work and the demos. But yeah, it should be really easy to add that for us as well. All right? Oh.
I think that Windows 10 is going to support the Tap to Miracast using NFC, right? And my question is if the Tap to Miracast can establish only the system level connection or the application layer connection?
The Tap to Miracast is really focused on the system level connections right now. Yeah. Any other questions I can help with? No? All right, I want to thank you for your time. Enjoy the movie tonight and enjoy the rest of the Build Conference. Thank you for coming.